So here's a quick explanation as to why the differences between the differences in a quadratic number pattern is always twice the number of n squareds in the nth term for that pattern. So hopefully that wasn't confusing, that weird sentence. Just maybe you've listened to it a couple of times, but I'm just going to say it one more time. The differences between the differences, hopefully if you watched my other video when I demonstrate how to find the nth term in a quadratic number pattern, you'll see the differences between the differences is always twice the number of n squareds in the nth term for your pattern, your quadratic pattern. Why is that? How can we prove that? Well, you've got to use algebra to prove that, because algebra shows things in a general way for every situation. So that's what I'm going to do here. I'm going to say if this is your nth term, an squared plus bn plus c, and any nth term, a quadratic nth term, can be written like that. A could be any number, b could be any number, c could be any number. Okay, then if you stick n equals 1 into this, you'll get the first term, n equals 2 into this, you'll get the second term, and n equals 3 into this quadratic nth term, you'll get the third term. So let's do that together to see what you get. So when n equals 1, it goes into this, that means that is 1 and that is 1. So you get 1 squared is 1 times a, so basically that's 1a or a. And b times 1 is b, and c by itself is c. So by putting n equals 1 into this quadratic nth term, you get a plus b plus c, and that's your first term. In a similar way, if you put n equals 2 into this, you'll get the second term, and n equals 3 into this will give you the third term. So all this stuff in the first bracket is the first term, then you got comma, then you got another set of brackets which basically means the second term, and this is the third term. Now I'm going to look at the differences and then the differences between them and show you that you get 2a every single time, basically. So to find the differences between the first two terms, you simply do that, take away that. So 4a take away a is 3a, 2b take away b is b, and c take away c is nothing. So basically the difference between these two terms is 3a plus b. The difference between these two terms is 5a plus b. You add from here to there, you add 3a plus b. From here to there, you add 5a plus b. Now the difference between these two, you simply do that, take away that, and so 5a take away 3a is 2a, b take away b is nothing. So basically the difference is 2a. And I've just shown you that in a general situation. So the difference between the differences is 2a. Now I could do a more general explanation where basically n equals n, and then in the next term, for the next term you do n plus 1. You substitute n plus 1 into this quadratic nth term. That's a bit longer, a bit more confusing, but this should suffice for now to show that for the first three terms, the difference between the differences is always 2a, i.e. twice the number of n squareds in the nth term for your quadratic